Hello and welcome to this webinar on Controller, Data-Centric Protection. My name is Steve Bradshaw of Road IT, and I'm joined by my good friend Guy Mamois. Today we're going to teach you about controlling access to your data, irrespective of how the data is actually accessed. You'll hear us use the term data-centric over and over again, and this is almost a philosophy that's at the heart of this product. What you're about to see is a series of demonstrations of common scenarios that we've seen in many of our client sites. It shows you how we can secure any type of access to IBMI, and by any, we literally mean any. New versions of access and methods are added with every version of the operating system, and quite often with new TR levels. But the way that we protect the system using the data-centric rules applies to all of them. We'll show you that installing Controller has zero impact on installation and a truly negligible overhead. In many cases, it's so small it is not measurable, and many people make this claim, but we're prepared to actually back it up and have testimonials to that end. We're also going to show you how we can remove the risk of during installation using what's called simulation mode. Now, this is at the heart of this product. The idea being that you can actually import and put in place security rules that are very specific and very absolute, but you simulate how they work first. So you watch the access. You see whether the rules that you would have turned on would have actually broken legitimate connections as well as your hacked connections. So we simulate everything before we put it live. So there is no risk of actually impacting your legitimate, normal, everyday use of the system. We've also built in some very handy and intelligent learning functions to help you configure the security on your system. And we'll offer you ways of actually securing the machine that may not become apparent. It will learn as it goes along. Now, the main thing about this is it complements your existing security rather than replaces it. So if you can put a lot of time and effort into classic adopted authority modes, the Controller software suite will sit alongside those and it will build upon them. You don't have to replace anything that you've already done. And as I mentioned at the outset, this is a truly data-centric total system protection. So regardless of how that data is being accessed, we can protect against it, and you can set simple rules to make sure that your data is kept safe. So both Cilasoft and Roden have been around for a lot of years. And in this time, we've managed to accrue a lot of experience. Now, I would ask you not to spend, I don't want to spend too much time worrying about this, but the information that you might need is on the screen right now. If you want to know a little bit more about us and our references, please just Google us. So, we're going to focus today on the Controller software. Now, you'll see that this forms part of the Cilasoft compliance suite, and it's up there in the top right-hand corner. It integrates seamlessly with the other products that you see there on the screen, but today let's focus purely on Controller and how it controls the access to your system. So, enough of my talk. It's time to introduce you to my good friend Guy Mamois, who's going to take you through our first scenario, which is a simple but of course very important one, which is going to manage and control the access to the data on our system via FTP and ODBC. Guy.
Thank you, Steve. Hello, everybody. So yeah, let's start with a simple one. When I mean simple, it doesn't mean it's you won't learn anything. So let's start with a simple FTP. So I'm connecting to my server using FileZilla. I'm just displaying the content of my library. So you see qsys.lib, ERP file, and then same thing as in the previous webinars. So I'm always targeting my client file, which is the most critical one, and I'm just getting the file on my PC. And also, just to be complete, I will also use a remote command to see how it appears on the system. Okay. Right, so it says display sysfile today successful. So let's now take a look in the control system in the graphical console, how we have been able to capture those events and how it looks like in the console. So in this first screen, you can see that we have many different systems, and in a unified view, we can see any transactions that have been accepted or rejected by systems. So we can set up different colors, see the connected system, not connected system, etc. So it's easy to group the system. It goes up to multiple hundreds of systems. So let's go to the 7.2 machine, and let's take a look at the controller log by user. So this is the activity for the last 24 hours. The blue part represents the accepted entries, and the red one, the rejected entries. As you could see, there are two different red and two different blue. This is simply because there are some with simulation mode and blocking modes. This is the reason why you see two different of colors. Right. So let's click on the GL. This is the profile I use for the scenario today. All right, so at the top of the screen, here are the most recent entries. So the logon of the FTP, it was the first event, and then you see a CD, so in the function column, okay, the logon, the CD, the get, the remote command. As Steve was mentioning, we try to be, we are data-centric, but we try to be. It means that every time we receive from the exit program, from the exit point, from IBM, a character string, we analyze the character string, and we try always to define what's that. Is it an object? If it's an object, we resolve the name of the object and the library, so we can be fully data-centric. So you see here, for example, when we did a CD, so we go inside the ERP file library. And then when we do the get, so we still keep the library to the qualified object, but also the name of the file. This is the IBM notation, and this is the way we do. If the FTP was touching an IFS file, it was set up in a different field, not in this one, because it's not an object. And the last one was a remote command. So the type of object is a command, not a file, and the object itself is the display val command, and the character string shows the full command with the parameters. If I double-click now on this first entry, logon, so you see the same thing. So, okay, the point, the date, time, the user, the job, the IP address, of course, and also additional information. When it's possible, we will always try to get this additional information. For example, in this case, we are able to tell you that this is a secure connection FTP. This is very important. Many customers are telling us how you're able just to reject any FTP, unencrypted FTP. How do you do that? So we can just decipher this field to say if we don't see TLSC, for example, value in the security parameter, we could reject the logon. The status here is accepted in simulation mode, so we are still in simulation mode. So if we take a look at the next one, this is the CD. Next one, this is the customer file with the get. And next one, this is the command itself. Now let's switch to another scenario, so ODBC. So just to simulate an ODBC, or not to simulate, but to do it, it's a client access transfer. So we will see how it looks like in the log. So let's connect using the same user. Okay, this is the result of the file. So I go here, I press F5 to refresh the screen, and I get now two new entries. Same thing, the logon, or the init in this case, this is the same, and the select. This is the download of the file. In fact, it's just a select statement. As you could see, IBM adds all the time for fetch only for client access transfer. If I double click on the init, we see also additional information exactly like FTP. Of course, it's a different one, but it mentioned a little bit about the client. It's not exactly a register, but it's a client information that it's available at the logon step. we can also reinforce the security based on this one. For example, we have customer that says, I don't want somebody to connect to the IBM data using Excel. So from there, we have the Excel program. So it's possible to make a rule and to prevent that. If I just check the next one, so this is the download itself. So the name of the file and the name of the library has been resolved and put it in the library and the object field so that we are really data-centric. So we can create rules based on that library and object instead of that. All right, so now let's switch to blocking mode and see how we can play with the rules. So the switch to blocking mode can also be done in the graphical interface. So let's go to controller, work with points. Right. So I would like to restrict the points to see just the points that are related to ODBC. So we have two exit points, or what we call control points, the ODBC logon and the ODBC request, two different points. The ODBC request is in simulation mode, has the same thing for the logon, and I would like now to switch to blocking mode. So I just right-click and set simulation mode no. Right? So let's try the same statement. So the logon has already been done, and now in real time you don't have to bounce the servers or absolutely nothing. In real time the job is blocked. The transaction, sorry, is blocked, not the job. Right? So let's go back to the log. Controller log by user, GM. All right. Maybe you could see that it's a little different color. It's not the same red from the previous one. If I double click on it, the status is different. It says rejected, not rejected in simulation mode. So it's really different. So you can report, for example, on the really rejected events and not only the simulation mode rejected events. So from there, I can right click on the event, and we have different menus to play with the rules. We call that condition list, or list in short. We could add event to list or edit list. So let's start with add event to list. The system is intelligent enough to calculate what's the best fit list. So it put at the top of this list of lists the best fit one. So you don't have to worry about, okay, which rule should I have to choose to authorize my transaction. It's always at the top.
So this would be one of those intelligent learning rules that I was talking about. The system tries to help you, teach you how to configure itself.
All right. So just add to this ACCDB2 list. Okay, it says entry added. So let's go back, try again. Wonderful. So works. If I try now to another file, for example, the transaction file, it is blocked simply because I have generated an entry in my rule that is specifically to the file that I was downloading. If I press F5 to refresh, I should see two new events, one black, which is accepted, and the other one, which is rejected. So double click, yeah. So the accepted one now, this is for the client file, it has been accepted, and you know also the reason why it has been accepted. The name of the control is this one, ACCDB2, so you can take a look at the rule and know the reason why. If I go for the next one, it's rejected. So now let's take a look at the rule structure so you will understand how it has been generated and how we could play with the rules. So instead of now having events to list, let's do edit. So the list will pop up in a moment. There we go. So this is the list. So what's the structure of this list? User, library, file, access, server. Access is a generic value that means read in general or update in general. When you see a %, it could be a partial value or it could be a % alone, which means anything. For example, if you have access equal to %, it means you can read, you can update, you can delete, you can insert whatever you want for the data. The rule that has been generated automatically with the add previously is this one. So we could see GM can read, download, the client file from the ERP file library using the server SQL server. This is the way it reads this rule. Keep in mind that all the rules have a customizable structure. You see here user library file access server, but for certain customers, they love to have group profiles and supplement group profiles concatenated with the user. They prefer also to have the function instead of this access generic value, so they are more precise for the rule. Or they could have also the IP address or whatever. So that's totally flexible. Of course, I could have also a command, so allow GM to read client file, for example. But I can also edit this rule and say, okay, let's say that any file that starts with GLF could be read by this user. Right, so let's save the change and then try again. All right, works.
Fantastic. So thanks, Guy. What we've learned then in that scenario is that we can create a simple simulated rule, put it in place, watch that it works, refine it so that it doesn't cause any negative impact, put it live, modify it whilst it's live to further suit the needs of the client based on what we've learned, automatically go forward and add it to a learning list and an intelligent set of rules, and further refine those rules and show how those rules can be modified and also documented. I like that feature. You can document what each rule did in the rule itself. So there's no separate documentation, no looking at a spreadsheet to try and work out what each of the rules do. You just look in the rule and it tells you. So that brings us to the end of this simulation. Join us in a moment for the next scenario. Okay, so let's move forward to scenario 2. In this scenario, we're going to use controller to manage the SQL access from the command line or call stack. Now this may sound very simple and it's easy to demonstrate, but it's very powerful and very difficult to do. We're very proud of it. Now what do I mean by this? Well, we all know that you can run SQL statements. They're embedded in RPG. They can be run from the start SQL command. They form part of Query 400. And you can even write your own application to run SQL statements from the command line, literally in minutes. But what's difficult, once you're inside these accesses, is blocking on an SQL statement by statement method what is allowed to actually access, update, or simply read the data. You have to remember that SQL is an incredibly powerful language. It can not only read data, it can update it, it can even destroy it. So, in this scenario, he's going to take you through a few of the basic parts, and then I'm going to emphasize afterwards the difference between normal modes and this data-centric approach that we're trying to build into controller and extol out there to the world. Guy, would you start the demonstration?
Sure, yeah. All right, so let's start with a simple run query command. So I'm still playing with the same file. Okay, so I'm just opening my client file using run query. All right, this is my file. Okay. So it's using the old engine. So there is no, for this old engine, so the Query 400 engine, there is no way to block at the, I would not say SQL statement, but I would say invocation basis, so it's not possible. But it's still possible to trigger an action to generate something that could simulate a rejection, like, for example, canceling the job or holding the job, etc. Now, more interestingly, this is the Start SQL, because within the Start SQL, we found many customers that are very afraid of this command, especially in production, especially in private banking environments, or demanding customers for audit compliance rules, etc. So they're just afraid because they don't know what's going on this command. And they cannot also prevent people running specific SQL statements using Start SQL. So within controller, it's possible to, number one, know exactly what's going on within Start SQL, but also block on a very granular basis at the functional level, at the file level, even analyze the where clause or to force to have a specific function within the SQL statement. So it's very powerful, and of course also, like Steve mentioned, to play with the code stack as well, to identify exactly where it's coming from. So let's run, for example, this SQL statement. Okay, it's a select. So let's take a look at what we have captured within the graphical interface. I press just F5 to refresh. All right, so we have captured a number of things. Interesting. So number one, this is the run query command, the full command. So it is the command itself. It is not the fact that it has accessed a file. So it's really a command exit point that has been used to capture that statement. If I double click on it, the interesting thing here is that we have also captured the IP address, the job, but also the code stack. So we know exactly that this specifically run query has been run from QCMD, which is the command line, and not a CLP.
So this is one of the points I wanted to highlight. If you can imagine, one of the things we have to protect from now is session hijacking. Now, what do I mean by that? Well, in this case, imagine that it's perfectly reasonable for this user to use this query as part of their standard ERP solution. It's embedded somewhere in it. But what they mustn't do is be able to run it directly from the command line, especially not if they have specific overrides in there. Imagine if it was a developer that had access to a development system, and they could run a query that selected all of the payroll information, our good old friend the payroll. But why would you want to let them do an override of this and actually then start accessing the data from a different set of tables? So yes, you could have object security in there, but the simple fact that this can be identified as to where it's run and when it's run, whether it's the IP address, whether it's the call stack, gives you infinitely more power and control.
Okay, so let's go to the next event that has been captured. In fact, it's related with the same type of event, but this is what we call DBMon, related to database monitor, that gives us more information about the name of the file that has been queried. It's at the end, this is the same, but it's a different source of information to get the same result. For the next one, this is the Start SQL command. This is the command itself. So we see the call stack is still the same. It's even if it's important to get that, because it can relate with the SQL statement that we capture just in the next event. So we know that it's coming from an SQL, Start SQL, simply because the Start SQL command was issued just before. And as you could see there, the call stack is still there, the IP address, and the full SQL statement, including the value of the clause where, is available. So you really can use everything from that, and more than that, to set up some rules and to block or to make actions, trigger pop-ups, etc.
Just to stress this point, it's really difficult to go into the logs and find out all of the information you see on the screen there. You look in many different places and you would struggle to find some of the facts that we've got on there. So having it all grouped together simply in one place is a real benefit from a system auditing point of view.
All right, and you know, the last thing I would like to show in this very short scenario is that it's so easy to create your own command to do an SQL statement. We know that run SQL is available on the system since 6.1, run SQL statement for many years. But it's so easy. Take a look at this one, for example. This is a command that we have built. It's so easy. I mean, just it's an execute immediate. So we have called this command FreeSQL. We put it in another library, so we can run any type of SQL statement with it. Boom.
So just in case you think Guy's making this up, what you've just seen there is even if you had blocked or removed the start SQL from your system, with just literally a couple of hours work, maybe even less, you can actually build your own version of Run SQL that you'd have to protect against. So using the rules we have in Controller, not only can you protect against the command access, whether it's the start SQL or the free SQL you see there, but we can use these data-centric rules that say, regardless of how this SQL statement was executed, whether it was embedded in RPG, whether it forms part of start SQL, doesn't matter. We can add rules to it to say this statement is legitimate if it's maybe part of an ERP and it's embedded, but we are going to block it in every other circumstance, or specifically we'll block it from the command line. The choice will be totally yours, and the rules are very easy to adapt.
So this is the command itself. So the Cila tools, that's the library, and FreeSQL, this is the command. And the next one is the SQL statement itself that was within the previous command. So yeah, that's...
So that brings us to the end of this scenario. I hope you appreciate it. It's short, it's to the point, but it's incredibly powerful, and it's this data-centric rules that you'll keep us here talking over and over again that's going to allow you to protect your system with intelligence and with a great deal of granularity. Thanks, and we'll join you in the next simulation in just a moment. Okay, so our third scenario is with using Controller to access DRDA, DDM, and NetServe. Now, I'm sure that all of you know what DRDA is or DDM, but just for those few that may not, DRDA has been around for a long time. In fact, the DDM predates the AS400. I used it back in my System 36 and System 38 days. Now, these protocols are very useful, and what they allow you to do is access information from a different server, so another IDMI server, from a second one. So you use one system to access the other. They can be incredibly useful, and they form the heart of many of our solutions. But the problem with this protocol, being as old as it is it was designed in a time when security wasn't as important. Any new implementations of protocols that we put onto the system really do have the Rochester team looking at security just as much as functionality and performance. Now, much has been done to improve this, but it's still not as granular and as easy to track as other types of connection. Now, using Controller, we can restore that granularity, and you get full control back and full auditability and all the flexibility of data-centric rules, even inside DDR and DRDA, my apologies, and DDM. Guy, would you start the demonstration?
Okay, Steve. So let's start with the DRDA. So now I am on another machine. I'm doing a start SQL, and then I will connect to a remote machine. In fact, still the same, the 7.2 machine, using my user GM, so the same user. All right, so that's just in the controller rule. We said that for any connect to the RDA, we would like to alert the people of the security team. So we know that GM is currently connected using this IP address from this system, so it's my 7.1 machine to my 7.2 machine.
So if any of you have been watching our other webinars on EAM or QJRA, you'll have learned a little bit more about these pop-ups and the different types of alerting we have. But just in case you haven't, what I need you to take away from this is that we can do real-time alerting, we can do ad hoc reporting, we can do alerts via emails, or just even create spool files. The flexibility is there, and you define these rules. So that was an example of a real-time pop-up. You wouldn't put it on the same screen normally as the person issuing the DRDA connection. It would normally pop up on the security compliance teams, so your sysadmins or a general alerting console. Key.
All right. So now that I'm connected to the remote machine, the 7.2, so I'm running an SQL statement to the remote machine, or I would say, to respect the name, to the remote database. So let's do that. So I am currently displaying the content of this file that is on the remote machine. So let's start to see what I've been able to capture using the GUI. So let's Let's refresh the screen. All right, so we have two different entries. One of them is coming from the DDM. This is in fact the connect statement. And the other one is, as you could see, the job name is the same. This is the select statement. Okay, so let's double click on it. So as Steve was mentioning in the beginning, so DRDA is an old protocol, so there is no direct exit point connected to the DRDA activity. So there is no standard way to control the SQL statement that are passed through the DRDA connectivity, right? So the exit point, traditional exit point, just gives you this information. This is the connect to database. So you just know that this user from this IP address is connecting from this system to this remote database. And the traditional way to say is, okay, you are allowed to connect. And that's it. There is no other way to block at a more granular level all the SQL statements that have been or that are passed after the connection. So just take a look at the next one. So this is the SQL statement that have been captured after the DRDA. So if you see, if you remember the job name, this is exactly the same job name that we have used for the connect to database. So same thing as the one that you have seen with ODBC. So the SQL statement is passed, so we resolve the name of the file, the name of the library, so we are data centric. And all the rules that we have seen for blocking mode, simulation mode, and it's also available for any type of SQL activities, including the RDA, of course. So that's one thing. So let's move to the next one, which is about DDM5. So let's continue to be on this machine. And on the 7.1 machine, so I have started, I need to have a DDM file that is in fact connected to my client file to the 7.2 machine. So I'm just doing a DFU on my DDM file. And just opening the file is captured by the exit point on DDM. And in this case also, we just trigger an alert. As you could see there, we see the profile, the name of the file, the library, the IP address, and the access type also to the file. So let's take a look at the entry within the log. All right, so this is one. Okay, it's a PowerPoint, so don't expect to see too much information on it, but at least you could see the IP address, the username, the job, and the name of the file and the name of the library. This is the important information. And you see also whether it's open in a read mode or in an update mode. So that's at least important. Let's take a look at the next part now. This is net server. Using net server, as you know, you can map the qsys.lib environment to the Windows. Okay? There is authorization list that can protect that, but okay, the exit point is also a very good way to prevent people to go, whether it's in the qsys.lib or in the IFS. It's absolutely the same. So, but I would just like to show you the qsys.lib because it's also a data-centric rule.
So many people realize that you can use NetServer to map to the IFS. That happens all the time. And even though IBM doesn't ship a root share, as you see using here by default, most sysadmins seem to turn it on, and it's convenient for them, but I don't think they realize that they're actually opening up data access not only to those nice file shares for the IFS, the traditional, oh, I will store my PDFs there, but also to the full DB2 environment, including the files. One or two of you now might be quite surprised about what he's going to show you.
Okay, so let's click on the library itself. So we could see our file. So again, the client file. So let's click on it and let's right click on the member of the file and send by mail. Yeah, and that's it. So I'm just stealing the client information.
And as you said there, stealing. That really is, no, it's right. We're going to pretend that you're a bad person. Guy, I know in real life you're a great guy, but if you hadn't set the authorities correctly, literally an entire copy of the file, that entire member, all of the data was just exported in a fraction of a second.
Yeah, correct. And so just have a look at it in a different way. So now let's take a look at the IFS. So we will be able to see, yeah, this is the one. So you see here all the list operations. So it's just a way to navigate within the directories in the IFS. We still can avoid to record that. Of course, it's possible, but just for education, so we see that. And then now we see that we have opened the file in a read mode. Okay, it's possible also to open in a update mode, but in that case was read mode. So this is what IBM passed as parameter, and so we resolve it, even if it's easy to resolve. But for the data-centric rule, we put it in the library and the object, just for also the same reason, to put the rules in place.
So, just to summarize what we've seen there, using the data-centric method and also the simulation mode, what we can do is protect our sensitive files. So we tell the system that in our case it was the ERP library, and you've seen that GLF client file. And let's just say that that's your sensitive file. So imagine your sensitive file there. You say that's what's important to me. And then in simulation mode, we put a data-centric rule on there, and the machine will automatically start learning how that's accessed. Now, why is that important? I said to you there was a zero risk with this, or as near zero as we can make it, risk of installing controller. Now, this is where this simulation mode comes into its own. You install controller, you tell it what the important sensitive files are, and then you start watching all of the data access. Now, I guarantee one thing will happen here. You'll do that, and you will know the vast majority of the ways that your users access your data, but you will learn a new way that you never knew that someone was getting to it. This will be highlighted, it'll be caught by the simulation, and then if you decide it's legitimate, you add it to the good rules. And if you say, I don't want this to happen, maybe go back and talk to a developer about how this new function is working, you can block it. And with that, we come to the end of this particular simulation. We'll join you again in just a moment. Moving on to scenario 4. In this scenario, we'll use controller to manage access to WebSphere applications. Okay? And specifically, we're going to be leveraging the power of SQL registers. Now, we'll explain a bit more about what SQL registers are as we move forward, but they're an intrinsic part of connecting and protecting WebSphere running on the same system or a connected system to your IBM I with your production data. So without further ado, Guy, would you take us into the scenario, please?
Okay, thank you. So the idea here is to replicate a situation where we have in some customers, so they have a generic profile, very powerful, that is doing critical transactions all the time, and they are afraid that somebody could use these powerful user profiles to do, of course, bad transaction. It had happened at some customers. So they asked us to reinforce the activity, to reinforce the protection of the activity of this specific user profile, to be 100% sure that nobody is hijacking this user profile to do other things. So it's not only based on traditional exit point and traditional methods, but it goes really further than just that. Imagine that, just to replicate that situation, I am currently using a tool that we have developed ourselves. It's just to replicate that. So my user profile is GM-Web. Imagine it's very important generic user profile that we do critical transactions. So I'm connecting to my my system I. So click connect. And then here I am just doing a select, still the same file. So currently my exit point for ODBC is in blocking mode. So if I run the SQL statement now, it says that it's rejected, right? You see, by the exit program, right? So now I would like to show you how I could trust this SQL statement only from the client application, right? So from there, I will just change the application name. So these are the SQL registers that Steve was just talking about in the introduction. So I will just change the application name and put something that we know that it's not public, you know. And I even could use one of these fields to put kind of a password inside, so nobody knows this password. So you are really sure that if somebody is trying to use this user profile, it would never guess the password. So it's just have to type it right. Okay. So these are all the registers. So now I click Change Registers. Then I click Run SQL. And as you could see, the SQL statement has been run successfully. If I change the program a little bit, so it's just adding a character, change the SQL registers, run the SQL, it's rejected. So it's a very fabulous way to add a strong layer of protection to the traditional one.
Now, for those of you who are thinking, yes, I know passwords, no matter how obscure, I can always brute force them. Well, of course, that's true. Given enough time and enough monkeys, of course they can be brute forced. But this will detect every time the statement is incorrect. So if it's just off by one character, we'll get the alerts. So if someone has tried to hijack, or sadly successfully hijacked your web server, and is now trying to use that as a way of getting into your back-end systems, not only will we pick up the alert the first time, but we can pick it up as they see the patterns for brute forcing. So one time wrong could be a developer. If we're getting 1,000 attempts in a single minute, then we know we've got something going absolutely wrong. We won't wait for the 1,000th one. We can block it on the first, the second, the third. We can set all sorts of granular rules at this point.
Okay, so let me show you now the inside of controller. So let's take a look at the control that is in charge of that. So, this control is, the name is, let me check SQL, this one, recheck SQL access based on registers. Okay, so this control is rejecting and logging. It is attached to all the points, so we can really pay any SQL type point, not only ODBC. If you have a discussion using the RDA, can be also available. And if you take a look at this, say, okay, this is the vocabulary that we are using. If the server is database monitor or SQL server or governor, and if the function is not called, take a look at the user and then take a look at this list. And if I press F4, so you will see this list is really a structure that we have defined, so it can be completely customized. So this is the name of the SQL register application, and this is the one for SQL program ID, right? So it says that anybody, any user that his name is GMWeb, coming from this IP address or this set of IP address, using the SQL server, if it comes from web app and if it uses a program ID like this, it will be allowed. If not, everything will be rejected based on this user. If I take a look at the log now, so just 5250 or so, just to show different ones, you will see something very interesting. It says the control, okay, you know the reason. It's not just because you are not authorized, it's really because you are using a powerful user profile outside of the SQL register rules specifically.
So there are 2 points I'd like to make from that one. Firstly, this builds on top of all of the existing security that you might have had in place before putting control in place. It goes on top of all the other data-centric rules that you might have created through controller, whether it's protocol-based, as many of the opposition would, or whether it's actually right down to the data level, or even the access type level as you're seeing now. All of these layers come together and every one will catch the security. So you're not dependent on all of them working. Any one of these tracking the nefarious, the bad action, it'll block the access to the data. The second one, a bit more of a simple thing, up until now in this demonstration, we've been using the graphical. And the graphical it's intuitive, it's easy to use, but it's not compulsory. So for those of you, like myself, that still love the green screen, we like our command lines, all of the inquiries that you've seen so far, they're still available for you to use from the green screen. So again, that takes us to the end of this simulation. Join us again in a moment when we move on to the next topic. Our final scenario for this webinar is about using true data-centric protection. You've heard me use the term a few times today, but in this scenario, we hope you agree, we save the best till last. So, what does data-centric protection give us? Well, in this scenario, what we're going to show is if we have some valuable data, we can put a simple and easy to enforce rule in place that will protect that file or those files against any type of access. Whether it's your traditional ERP, whether it's the ODBC, JDBC, whether it's the DA access, whether it's FTP, SFTP family, whether it's an integration with a WebSphere server, or any other, and by any other I mean including any new open source application, one that hasn't even been thought of yet and brought to the system. Using the data-centric rules, we can guarantee protection against the data on your system. So, with that lofty claim of being able to protect us no matter what the circumstance, Guy, this had better be a good demonstration.
Oh, okay, I will try to do my best. Okay, so let's start with a PuTTY connection. Then the second one will be a QP2 term. I will copy the file in the IFS. I will attempt to copy the file to the IFS. And another one will be the QSH first, to see what we can collect with the traditional exit ports, right? So let's start with the PuTTY. So connecting to my server. Okay, I am using a powerful user profile, but without command line, just for fun. Just to show you that with PuTTY, the command line access doesn't mean anything. Also, so let's copy the DB2 type. Oh, sorry, this is the password first. All right, so I'm connected to the PuTTY session. So, and then I run this SQL statement using the DB2 command. Well, I mean, let's say command, maybe function, right?
Okay, so what many people don't realize, they see the SSH function that's added to IDMI, and they put it on there because they've heard that FTP is bad and SFTP is good, and they want to use these SFTP and CP commands to do secure copies. What they don't realize is at the same time they've opened up their system to an extra command line, a command line that's just as easy to use as the telnet 5250 we used to, and as you've just demonstrated, allows you to bypass the limit command line capability and still run statements. Okay.
All right. So let's continue with QSH. So we'll now go to a 5250 session, this one for example, and then run the command. Okay, it's not nice, but it's there. So yeah, I was able to get the content of this critical file using QSH. Next one, and last one. So I do a QP2 term. And, all right, I'm doing a CP to copy the file to the IFS. All right, so it's not very wordy, but it's successful. So within these three functions, I would like to know what I've been able to get. So let's take a look at the by user. So I did some from GM. And as you could see, there is absolutely nothing. The other one was from the previous scenario, but nothing related to CP or to QSH. Let's go to the TM2.
Oh, just before you move from there, Guy, you might be thinking, well, surely there's something wrong here. The system's not correctly configured. There's nothing there. What we need to highlight here is that there are no exit points for the functions you've just added. Particularly when we look at the SSH ones, SSH sits slightly outside of the normal operating system parameters, and it doesn't integrate and give you granular access with exit points like traditional IDMI functions would. Now, these doesn't mean you shouldn't use these functions. SFTP is infinitely better than FTP, but it means it brings these extra risks, and we'll see these extra risks over and over again as we use these new open source software pieces. Sorry, please carry on.
Yeah, true. And we received many questions from customers saying that, okay, we would like to protect SFTP like we can protect FTPS. So SFTP and FTPS are completely different. SFTP is more in the Unix world. IBM has not provided any exit point for any Unix type of activity, command, or function, whatever you call it. So there is absolutely no traditional way to protect any Unix type activity on the IBM. All right, so interesting. So this is what we see, and now let's talk about the solution. The solution is the real data-centric exit point. This is called database file, open database file, sorry. This is an exit point that is 100% data-centric. It is based on the files that are on the auditing value. So all the files that are with audit value *all, they can be blocked by this specific exit point. Let's take a look. So number one, we will activate this exit point. Open DBF. This is the way I have called it logically. This is the IBM name. So right now it's held and in simulation mode. So I'm just changing it to simulation mode no, held no. And in real time, let's take a look at the effect. Just getting another session. And okay, let's play with my application. Okay, this is my normal ERP that has access to my client file. As you could see there, I can access the file, absolutely no problem. Let's do display physical file member of the same file. Fail. Let's do a DFU. Fail. Let's do start SQL and run the same command same statement that we used in previous scenario. Fail. Interesting. Let's go to the log to see what we have been able to capture first. So let's go back, for example, byteport, just to change a little bit. And then we're at, okay, open DBF. All right, so we have captured 5 entries, 1 accepted and all the other 1 rejected. Let's take a look at the accepted one. This accepted one, you see, okay, the user, the job, the IP address, the file, the library, and the code stack. So we know exactly what program has been successfully opened, what file and what library as well. We have also additional information, whether about the interface, whether it's direct access to the file or it's an SQL interface, or it's a query interface, or other. You have 6 or 7 types of interfaces that are available also on this information. Another thing is how the file has been opened, whether it's in update mode, read mode, whether it's through a logical file or view. So everything is available, so you could really make customized rules to say I accept or I reject. This is a very, very big thema, we say in English, thema, in the private banking sector, but also in the casino, also in or any company that manage confidential data like credit card information as well, very important. So we really could block any open outside of the application to your critical data. This is big. So let's take a look at the next one. For example, here, it was the display physical file member. As you could see, the code stack is a different one. This is the interactive SQL, start SQL. All right, so we have also the information available. All right, so let's now go to the other scenario that we were using just previously, the PuTTY one. So I should maybe restart the PuTTY. PuTTY. All right, so let's now connect to GM. Right, and copy the DB2 option that I just used previously. Access denied. Yeah, I used the wrong password. Sorry. Password. Okay, I'm connected. And then it should have been rejected. So for some reason it's not rejected. Maybe because it's in the spool file. It's, yeah, maybe it's from EMP file, GNF file. Yes. Okay. So you see the open failed due to exit program, right? So the other one is probably because it's submitted, so we don't have seen the rejection directly within the screen.
But we would get the rejection in the job log.
Yeah, we should. And here, let's start with the QP2 term. All right, and then do the CP again. All right, so the error is not so clear, but I mean, it still said that there is an error number, so we are not, we were not successful to copy the file. And
we don't mind if the error messages for the bad guys aren't that clear, as long as they don't get the data.
The QSH now. Oops, sorry. Yeah. So we have also this error. So error found opening the file, but now the message is maybe a little bit more clear. Okay, open the file, failed. The information that you see here is just from the previous request, and it's absolutely not related with that. So if we take a look at the log now, and I press just F5 to refresh, so we see everything related with forms. In some time, the IP address doesn't show up because it's impossible to get it. But you still have information. For example, here it was the probably the CP, the CP1. It's not easy to know exactly, but you know that it's coming from the programs that are related with Unix. You know, so that's the way.
Okay, so that's great. Now, I better pause for a second because I promised that if we use this method, that we could actually protect from any sort of open source application, whether it's been written or not at the moment. So what was that claim based on? Just in case you haven't picked it up, this concept of using the exit point on the open database file is like having an extra safe around your main. By safe, I mean a security safe, a thing with a key and a combination. Now, you take that valuable data and you wrap it in an extra safe. And there's this extra layer, regardless of whether IBM has created an exit point for any of these open source or Unix products, or people like Guy knew where the exit points didn't exist and were using the SSH ones, they still actually have to open the data file even to copy it. Whether it's a good old-fashioned DSP-PFM, whether you're using that export method via net server, whether you're FTPing it off, you can't take the data without actually opening the file. That's just a fundamental way that DB2 works and has always worked. So by protecting using the open database exit point, what that allows us to do is guarantee that we can control the access to the data. because however it got there, whatever system it was, if it wants to steal the data, it has to try and open the data. Now, you might think, well, that sounds great, but that's a huge overhead. We'll go back to one of our earlier points in the opening part of the presentation. This is an IDMI exit point that's at the heart of it, and so these fire all the time, in literally thousands of times a minute on a busy system, maybe even tens of thousands of times per minute. And so they are built in and operate at the lowest possible level with a minimum amount of overhead. And with a great deal of time and effort, the controls that we built in with controller also leverage these and again add a minimal, almost negligible, unmeasurable overhead. We take great pride in that. In fact, the very tools that you saw using earlier were designed not to simulate hackers, but actually to measure the speed at which things execute. And one of the other benefits of using this tool that I like, you might have seen it at every point when we've opened up all of these queries, it told you the exact execution time in milliseconds of the query that went in. So that can be kind of nice when you're doing performance monitoring as well. But that's a different subject to a different day. So this brings us to the end of today's demonstration. So I'm going to wrap this up and come and join you in a moment with some closing thoughts. So as we draw to a close of this particular webinar on controller, there's a couple of things I'd like to talk about first. If you've seen any of our other webinars, like the ones on EAM, you'll see how they can integrate into QJRM. These are the sister tools in the Cila suite of controller. And used together, they can be very powerful indeed. So you've seen a lot of protection today, but it might be useful to be able to do some reporting to amalgamate any hacks that have happened and see them all in context. So before we do the final wind-up key, could you just show us an example of a report that QJRM could use with controller information?
Okay, Steve, no problem. So this is the command that we'll use. In fact, it's a query in QJRM that is already defined. This query is based on user entries that are sent by controller. So the user entries, so it's just journal, okay, journal entries, they are sent in just specific situations because as you see, we have controls that can define in which situation, in a very granular way, what we have to send to the journal. So I just want to show you the report. So I just run this for today. So you will see all the scenarios that we have done during the day. It has to come to my mailbox with the same format as all the QJRM reports that we have seen in the previous sessions. So let's take a look at this one. All right, so a little bit bigger. Okay, so this one, oops, sorry. Okay, this one is taking a look at the journal for the current day. It's extracting 188 records from the journal. It's a specific journal, nothing related to audit, the system audit journal or database journal. It's just a journal with user entries. Like you see, the operation group is U for user entries. And at the end, it's just 43 records that have been kept. So just take a look a little bit at what we have. So we get the full SQL statement, the job, the IP address, the user. Of course, everything is customizable, but we get also some additional information like the SQL client application, the SQL client program, the estimated CPU milliseconds, and you know, Steve, it could be a subject for another series of webinars because we don't have time today, but we can play with that as well. So we'll see in the future. See whether it was in simulation or yes or no, and the decision. And we also have a mechanism to put some colors. So the rejected events are, yeah, maybe the red is not is very strong, but it's just to show that it was rejected. So I just would like to show you that before the end. And you see the estimated CPU milliseconds. Yeah, it's changing depending on the type of query that has run. All right.
So this is another classic example of augmenting information from a number of sources and bringing them together in an easy to understand way. Now, it's very important to have reports like that because Yes, we set our machines up and we make the best decisions we can, but we can't lock them down so absolutely that the machine can't be used, and we live in changing worlds. So we want to be able to look back at patterns that happen over time and see when things have been rejected, both in simulation and in real time, and see when they started to happen. So even though we've got control of protecting our data, we might actually want to reach out to the network boys and say, okay, something clearly bad is trying to happen to my machine. I'm protecting my machine from this bad attack, but could you please stop this person from getting into my network in the first place? There's always a reason for wanting to have that information. But I've spoken enough for today. I hope you found it useful and worthwhile. If you'd like to know more about the products, you can see our websites there, and also both Guy and my own email address at the bottom. If you have any questions, please feel free to email us. We'll do our best to answer them as quickly as we can. And with that, both Guy and I would like to say thank you for your time today.
Thank you.
Thank you.